Okay. When Francisco asked me to make 2 presentations, I didn't know that I was the only one to do 2. I feel a bit overexposed. So today I will talk to you about the functional size measurement patterns. It's a new concept. In fact, it's not so new because those who have some experience in Cosmic probably use patterns, but they don't know they use patterns. Okay, I will explain that. Again, I will start from my work and my experience at work as a professor at university. Since 6 years, I'm teaching software project management. And in this teaching, one of the little part, as Mr. Goldorat mentioned this morning, is estimation. And in estimation, this course is 6 full days. 2 days, Friday, Saturday, 2 weeks later, another 2 days, and the last 2 days, 2 weeks later. So for the estimation, I use a day and a half. But in this estimation part, we have requirements. Even if the students were supposed to have followed a requirement course, some don't know at all. I also have to tell them how to use work breakdown structure, to analyze the activities, and talk about IceBag, or if you prefer ISBSG, I prefer to say IceBag, it's faster, okay? And in that, this half day, I have to divide that in 2, 90 minutes to explain how to use IceBag, and only 90 minutes to tell them how to measure Cosmic and be up and running after that to measure their project. So I have to do that quite very fast. Those students also are very diversified. Some just finished their baccalaureate and going to master. Some have experience in the industry since many years. Some are coming from the software management, software engineering, others from IT. There's people from different countries. So very, very diversified. So when I want to teach quickly Cosmic, how to use Cosmic, not to know the rules, which is another thing, but to use it and measure effectively. So I was thinking of the Pareto rules, the 80-20, 80% of the rules probably are simple and repetitive, and 20% are more difficult. So I concentrate on the 80%. I don't want to teach them the difficult part. So from there, I have to push 2 times if I remember. Well, this is the button. Yesterday it was working. I don't know why it's not working today. Somebody can help? Because this is the button. Oh, okay, it's okay. Sorry, I make a mistake. I follow the arrow. Okay, I will make an introduction, present you the methodology of defining functional size measurement pattern, and a demonstration of how to estimate size with the pattern. And I have 2 conclusions. Cosmic, it's a functional measure, as you know. Probably most of you know already Cosmic. If somebody don't know Cosmic, I'm sorry. I will try to explain very quickly. It's a measure of size. We can also measure the quality. I think this morning Pekka mentioned that. And maintainability and so on. We can do many things with Cosmic. Okay, what is Cosmic? Cosmic, in fact, was constructed in the concept that in the software, we have a good number of little process. Each process have an input, processing, and output. And software, if you think of that, is always like that. We have many little process, input, processing, output. So what we want to measure is the functional process itself, and for that we use as input entry, output it's called exit. The functional process itself have read and write for the data movement. Entry, exit, read, write are each a type of data movement. Another thing also about functional user is not just a human. It could be another software, a device like a laser beam, okay, or a clock, okay? So it's not only a human user. And it's important when we want to measure a real-time system. Today I will concentrate more on MIS type of system because we don't have very much time, but we can do this kind of pattern with real-time system also. Why using pattern and why border if? You know, an individual, when he measure or doing a work, develop an expertise, okay? My PhD was in the cognitive science, so I developed an expert system in the context of my PhD. He developed an expertise, and this expertise, it constructs some pattern in his head, in this expertise. And why bother to define the pattern is because if we define correctly a pattern, if we try to define what we are doing, we will improve. Okay, if we don't do that, we will improve, but not as fast. Okay, I use pattern, explain pattern to my student because they are not experienced. I want to help them to build a cognitive process through different examples in 90 minutes, okay? And they are able, after that, with some help of my part during the semester, to measure the project. And since 6 years, I'm teaching this course every year. I have many students. It always works, okay? We want also reducing the measurement effort. It's like driving a car. The first time you drive a car, it's a long time away for me. After an hour, you are exhausted because you have to think of everything, what to do, turn left, push the pedal, everything. After a time, you don't even think of that. And you can drive for 5 hours, 6 hours, and you are not tired. It's the same thing when we measure at the beginning. It's a very intensive process, difficult. After that, it's a kind of automatism, and it's going very fast. Also, we want to size project in an early phase. This morning, we talked a little bit about the risk. There's a big risk if we don't know exactly, we don't have all the requirements, as Becca mentioned. And when we have some expertise, we remember that, suppose I say I want to maintain a client file, okay? We know that we add, modify, delete, things like that are different processes. And most of the time, we forgot to mention query. And we know by experience that, oh, if we forgot the query, I'm sure in the system there's a query somewhere, or there's a list somewhere. So we complete, in a certain way, the thinking of those who are doing the requirements. And it helped to assuring accuracy of measurement. And we have, this morning I mentioned that briefly in my question, we have a document about accuracy of measurement in the cosmic sizing site. Okay. So we want to define, and I work on that with Sylvie Trudel from University of Quebec in Montreal. Probably some of you know her. And to design the science research methodology of that, okay? So then this design will help to inexperienced measurer, okay, reduce the measurement effort because we construct pattern, allow early sizing, and provide more accurate sizing. The definition of a functional size measurement pattern is a predefined generic software model solving a recurrent measurement problem in a specific context. This is the scientific definition of pattern. And it mostly, if you know cosmic methodology, it's mostly applied in the mapping phase of cosmic. Okay, there's different phases, and it's mostly applied the mapping phase with functional process, data group, and data model. There are different categories of FSM pattern, and there are 4, in fact. The micro, partial functional, the basic, the composite, and multi-composite, set of composite and basic. Each one is a kind of Lego that add, is a pyramid that adds. So the pattern can be applied both IS and embedded real-time domain software domain. I say over 4 years, but now it's 6 years because we presented that 2 years ago, the first one. I know that it helped the novice, my student, but I don't know exactly how much because I can hit myself because I didn't measure the effect. But when you are doing a course on project management, you have a lot more things to do than just the sizing. So that's why I didn't have time to do that. But eventually, I shall do that. 2 years ago, it was the first conference on pattern, okay, and it's the second one. It's very new. Okay. Micro FSM pattern example. Suppose we have an error message. It's at the level of a data movement. Okay, error message is the data movement. We display localized error message and so on. And then at the end, we arrive with one data movement, which is 1 point with cosmic. Okay. Basic FSM pattern example. We want to create an occurrence of a data group, retrieve and display a data group, update or delete. We use a create, retrieve, update, delete. I'm used to say add, modify, delete query, but we use the term because it's the acronym will be CRUD, C-R-U-D, okay? And I will use this acronym later. So when we use that, we have create an occurrence. We have an entry, a read, write, and then we have error message just for create. We can repeat that for retrieve, update, and delete. So we have then example of CRUD, C-R-U-D plus L. L is for list, okay? Then we have create. We use 3 data group. We have 3 point, entry, read, write. We have the second one, 2 read, exit, and 1 error message. If we look the create after the same create, retrieve, we have already 8 point. The update, retrieve, update is the same as create, and delete, we have the first data group and message error, it's 4 point. And a list will be a message, a filter, then we have entry, exit, entry, read and exit, then we have 8 point. So we assume there that if we have a data group, 3 data group, we will have 36 point, applying the CRUD, the create, retrieve, update, delete, and the list. So this is a pattern. I'm looking, I know that I have to maintain a number of data group, and I already know there is 36 point there. It's not fully true. There's a margin of error, but as I mentioned, I cover 80%, okay, which is important. So first, second, third. Multi-composite module using the data group. we have different categories: master data, transaction, reference. Suppose we have a crude with 3 DG, we have 36 points. We also find a crude L 2 times composite with 40 points, and we have different crude. So we define what is the crude, and when we saw that in the requirements, we know that it's 36 points, 40, 22, 52, and at the end, we have 220 points for that. It's not a perfect measure, but we have a good idea very quickly. At least for my student, they are able to measure. They are not stopped by all the little rules. I'm very quick. I'm giving an example with a case. This case is provided by a student who have done the work in my course. It's in French normally, but they have done it in English, so I use this English text. The aim of the application is to provide a project plan for the AUC dashboard. So AUC dashboard means we want to know the status. If it's red, it's bad. Amber is acceptable, but action must be taken. And green is all well, continue improvement status. Okay, this is a case. This case have a number of constraints and assumptions. Of course, I will not use a constraint and assumption for the measure of the cosmic function point. It's used later when we want to know how many hours per function point. It's used later with IceBag. But I will mention that. Data access will be granted by the Firm Security Division. Only authorized and trained personnel will interact with the system. So it's a question of security and other things like that. Data group. How many data group we have in this example? I found parameters with a system name, description, cost, and owner. A quality measure element. Those who don't know what is a quality measure element, there is an ISO standard on that. It's a 25, 20, 21, okay, 25021. And also derived measure. This is also defined in the standard, ISO standard. And the quality measure have the description level, number, value, and so on. So at the micro level, the example, with this example, we have the status of the system. One data, is it red, amber, or the different color? At the FSM, basic FSM pattern, what we add, I say add parameters is my way to. Then we have 3 data movement and 3 read, write, and 4, in fact, with the exit. Note the exit is for the error message. The data movement, we have 3 if we consider only the data, but the error message, then we have 4 data movements. So because the system name, description, cost, and so on, okay. Then we have the basic FSM pattern for data movement with this one, and it's the same example I gave before. A composite pattern, we have one of the things the student identify, calculate RAG status, the red color, amber, or red, amber, or green. What is the status? There is 2 data group for that. If we use add system, we have 1 data group. Modify 1 data group, delete 1 data group, display, search RAG status, 2 data group. So we assumed 4 data movement with 1 DG and 6 with 2 data group. A total of 32 data movement, okay? In reality, when we continue the project, we found some more information, and we arrive at 49 points, mainly because 2 new processes were added. So we discovered that the requirements were not complete. So that's why there is more point. But in general, if we in this case, if we don't consider the two new data processors, the difference is about 2 or 3 points. It's not so big. So with multi-composite FSM pattern, well, we had all the other pattern, the pattern, the composite pattern. We had all that. If we have new one, then it's like this one here. I don't give the example here, but this is, if we have more crude, we add different crude. I will finish. Okay, my first conclusion, and it's, yes, I was very quick. It's good because it's the second day and it's at the end. We use a design science research methodology. We introduce the concept of as a mean to help inexperienced user to ramp up their learning curve faster. Avoid measurement mistake because we deal with experience in that. Reduce measurement effort because we don't have to put so much effort when we know the pattern, and assist in measuring project and early phases. In fact, this morning I was talking with somebody, I cannot remember who, he said, yes, we have a questionnaire, and with the questionnaire, I think it was Harold, and we can have question and have the number of cosmic function point with question. It is a way, it's a tool. We can construct a tool like that and do the same thing that I'm doing there. With the student, I avoid to use tool, except Excel, but for me, Excel is a blank sheet, okay? It's not really a tool. And I avoid that because I want to be, have the possibility to use other tool later or something else. So, but they have the basic information. For Cosmic, the opportunity is to new approach for early sizing because we have a good idea with the pattern, where we are going. Micro and basic FSM pattern to be included in training material. Now it's not included, but eventually we'll include that. Perhaps it's already included since 2 years, but I'm not teaching Cosmic officially on a regular basis. I'm just teaching software project management. Future work, provide quantitative for evaluation of SM pattern against the research objective. Yes, of course, I'm teaching my student, they provide some result, and I should know how successful they are in their measure when I'm teaching like that. Okay, it's a thing I have to do eventually. And to know also the learning curve. I have to say that after the 90 minutes, the course is going on. It's in the first 2 days that I'm giving that. So later, I have a meeting with my student for other part, but they can ask me questions about, I can help them about the project measurement, part of the measurement. So sometimes I have to tweak a little bit to have a good result because they have a chance to have a follow-up. Library of FSN need to be developed and taught. New types of report, batch FP, and et cetera. Also a lot more for the real-time system. And it should be made available freely for the community. Cosmic, we are doing a lot of things for free. We are doing a lot of jobs for free also. And also looking for automation when we'll have enough things. Probably never 100%, but if we have the 80-20, I will be happy. Thank you.
Agradecemos a Jean-Marc Desharnais por su conferencia.